We're going to prove another theorem about parallelograms, and this one says that if a quadrilateral is a parallelogram, then the consecutive angles are supplementary. So let's go ahead and write that out. Our statement says that if a quadrilateral is a parallelogram, then the consecutive angles are supplementary. So this one's a little bit odd because there's more than just one pair of or two pairs of consecutive angles. There's actually, I guess 4 pairs of consecutive angles. And so I'm only going to prove this once just because, again, I could repeat this, several times to prove all my pairs of consecutive angles supplementary. But one will suffice for me for right now. And I guess before I get too much into this, I should really talk about what does it mean to be consecutive angles. So we have our opposite angles. So for example, angle A and angle C are opposite angles, and so are B and D. But then consecutive angles would be like one when I'm following my vertices around, the ones that are next to each other, so consecutive in order. So for example, angle A and angle B would be consecutive angles, and B and C and D and A and D as well. And so what I want to do is prove that the consecutive angles are supplementary to each other. And so this might actually be probably our easiest property to prove about parallelograms. So we're just going to go ahead and knock it out. So ABCD is a parallelogram. That will be my first given, or my only given. And what I'm trying to prove is I'm just going to pick a pair here. Let's go with A and D. Angle A is supplementary to angle D. That's my goal. All right. And again, I could have picked any of these. And in reality, should I probably prove this about all of them? Yeah, but really, like I said, I'm just going to repeat the same thing over again. So I'm just going to do it for the one time. So ABCD is a parallelogram. That was given to me. And then, all right, so I'm not going to draw anything in. I'm just going to use the definition of what a parallelogram is. So I'm going to just, in fact, I'm only going to do this with one of the pairs. I'm going to talk about A, B, and CD being parallel to each other. AB is parallel to CD. That's my definition of a parallelogram. It says that if a quadrilateral is a parallelogram, or actually, oh man, that's garbage. I was writing a theorem. I need this if and only if. A quadrilateral, this is better, is a parallelogram. Parallelogram. If and only if the opposite sides are parallel. That comes from 1. All right, so I've said that A, B, and C, D are parallel to each other, and so what I'm going to use is just what I know about parallel lines. So I'm going to extend these out so it's a little bit more obvious, but A, B, and C, D are my parallel lines, and their transversal is AD. And so what do I know about these angles here, these consecutive angles, angle A and angle D, and that is, well, they are supplementary to each other. The reason I know that is it's because it's my consecutive interior angle theorem. And so that's all I really need to do is talk about the fact that these lines are parallel, and I can use my consecutive interior angle theorem to say this. So I can go straight to angle A is supplementary to angle D, and the reason for it will be that if two lines are parallel, then the consecutive interior angles are supplementary. Easy as that. So only 3 statements in. I've already got what I needed to. This goes back to 2. And so this was one that I might actually be willing to go around and prove all the pairs, but I'm not. And so this is all I need to say. So this is just another one of these properties for parallelograms. It says that if a quadrilateral is a parallelogram, then the consecutive angles, so the angles that are right next to each other, the adjacent angles that are, well, no, I don't want to call them adjacent, consecutive angles, will always be supplementary, and it's because these lines are parallel. So that's another property that we have for parallelograms, one of the many.